Okay. Hi, Caden. How you doing?
Good, how are you?
I'm okay. Don't have COVID, so that's good.
Yeah.
Looks like it's increasing again. Let's wait a minute or two here. Maybe one or more people will show up. Although Monday hasn't been well attended, so
It
yeah.
works good for me, so that's why.
Yeah. So I did finish the grading for exam 2, and you can review exam 2 if you'd like. It'll give you the specific feedback and kind of show you which questions you got wrong. I was going to say a little bit about the essay questions. I don't write a lot, but I do usually put down, you know, here you can add more details. That would be helpful. Or if you might want to check some details sometimes. And I don't remember what you wrote, but sometimes people are writing very general things. Like there was a question about water, and they'll just write like, water's essential, you have to have it, you'll die without it. And that's all true, but it's not, you know, I want you to explain why it's important, what it does for people. You know, there's a nice little section that says, you know, water is a good solvent. Water remains a liquid at a wide range of temperatures or at body temperature, and that water is good at holding heat or transferring heat, and that water participates in chemical reactions. And those are the kind of details. And then other times people write things that are kind of general knowledge type stuff. And so they'll say, water is important for flushing toxins. And well, people say that kind of stuff, but it's not, it's kind of an urban legend. It's not really something that we talk about in science. And so to kind of go to the specifics, why, you know, a lot of people included water was 60% of the human body. Water's in blood. Water's in cerebral spinal fluid. Water is inside of our cells. And those are the kind of details I wanted. And that it's a really good solvent because water has hydrogen bonds. And so it's good at dissolving proteins and all sorts of things. So that's kind of what I was looking for. And so often when I say add more details, I want those specific details that are kind of verified by science in the textbook. And then some people drift off into, you know, if you didn't have skin, your organs would fall out, something like that. And so that's kind of what we want to stay away from. Well, nobody's here yet, so let me share a screen or two and talk about this week. So, okay, this is a long, hard chapter on the endocrine system. We did the nervous system, and now we're doing the endocrine system. And so this is our system of glands, and so these glands that are all over the body. And they, you know, there was a little bit on negative feedback and homeostasis. And so this is a big homeostasis negative feedback system kind of week. And so these things here are kind of long-term homeostatic mechanisms controlled by these glands, growth, metabolism. And so it's this list of functions, and here are the list of glands that do it. Um, the biggest kind of most important thing is the homeostasis. That this is how we maintain a good internal environment is with our glands. And so it's this endocrine system that's doing this. Okay, so you see that, I should ask, do you see the slides, the endocrine slides?
Yeah, I can.
Okay, so then there's a couple long sections on hormones and how hormones work. There are little chemical signals that are transported in the blood, and they're going to act as cells that have receptors for them. Okay, and so a hormone is secreted and then just dumped into the blood, and the cell has to have a receptor for it, and then it can work at the cell. Some hormones are like fatty molecules, like the steroid hormones, like testosterone and estrogen. And these hormones, the receptor for them is in the nucleus, and they change what proteins are made by DNA. And so this includes thyroid hormones, testosterone, estrogen, and these are going to have long-lasting effects, although they're kind of slow to get going. Then there are water-soluble hormones. These are hormones that are going to act at the surface of the cell. They never get inside. But they cause a change inside the cell. That's called a second messenger. Okay, and so all hormones exert their effect through some sort of receptor. Okay. So then in this program, I talk about the pituitary gland. That's the most important gland. It's kind of, sometimes it's called the master gland, and that it controls other glands. And so the pituitary gland, it's actually split into two parts, a posterior and an anterior part. The posterior part is shown on the left here. The anterior part is shown on the right. These are kind of long-term homeostatic effects, growth and development, that kind of stuff. So like growth hormone, that growth of the entire body. The sex hormones cause puberty, sexual maturation, and then the maintenance of tissues. The thyroid gland controls metabolism. The adrenal cortex, that controls stress-related responses, and perhaps you can think of that as like salt and blood pressure, things like that. I just wanted to go, this gland though has really complex control, because it's the gland is at least in part controlled by the brain and the hypothalamus. And the hypothalamus can signal the gland by releasing what are called releasing hormones. Like in the case of the sex hormones, they're called gonadotropin releasing hormones. And they cause the anterior pituitary gland to release a hormone, either follicle stimulating hormone or luteinizing hormone. And that causes the testes to release testosterone. So it's this long chain of events where it's negative feedback systems are controlling the production of these things through kind of this indirect pathway. So my joke about testosterone is that testosterone is the hormone that makes men good looking and intelligent and and like that. And then I show pictures of kind of crazy male activities like wrestling. But there are these feedback loops, and these feedback loops can be affected how the environment is to respond to the environment, and the environment to respond to us. And so this is true not just for men, but also for women. Women have kind of the same situation, but instead of having a testy, they have an ovary, and it responds to the production of follicle stimulating hormone and luteinizing hormone by producing estrogen. And that produces the female characteristics. Um, the other kind of thing your book talks about with these guys is that that sometimes environmental chemicals can mimic hormones. And so with environmental chemicals like phthalates and bisphenol A, which is a plasticizer that makes plastic soft, these compounds resemble estrogen and progesterone. And so they can mimic the effects of these chemicals and cause an exaggeration or an interference with normal chemicals. And so these are endocrine disruptors. And so important, very, very important. And so the most important endocrine disruptors are these phthalates and bisphenol A or BPA. And these are, we think they're causing a bunch of endocrine problems related to the sex hormones and then also possibly related to other hormones. So that's a really important thing. So there's lots of glands here in this chapter. The pituitary glands are important glands. And then the other really important gland that I'd like you to focus on is the pancreas. The pancreas is in the abdominal cavity, and it's right below the small intestine, and it kind of works as a partner to the digestive system. It actually produces some digestive enzymes, but then parts of the pancreas also produce hormones that are involved in controlling blood sugar. And of course, the most common nutrient in the blood is glucose, the blood sugar. And so the two hormones produced by the pancreas, insulin and glucagon, make sure the levels of glucose stay in a kind of a normal range. If glucose levels get high, insulin is secreted by the pancreas to help cells reduce the amount of insulin that's in the blood. And so cells start reduce the amount of sugar in the blood. So cells start using sugar. They start taking sugar out of the blood and storing it as fat or glycogen, or they use it as a source of energy. Between meals, when blood sugar falls, then glucagon is released by cells in the pancreas, and that causes the liver to release glucose by converting stored sugar into sugar that can be used, and it helps cells use fat as a source of energy. Okay, and this is really important because of diabetes. Diabetes is a hormonal disorder where we lose the ability to regulate blood sugar. Okay, there's two types of diabetes. One is caused by an autoimmune attack on the pancreas. The other is caused by insulin insensitivity, where we just stop responding to insulin. And these affect millions of Americans. In fact, almost 10% of Americans, 25 million Americans, have diabetes, and even more have pre-diabetic syndromes that are associated with this. And so this is associated with the consumption of the modern diet, inactivity, accumulation of body fat. Certain people are more susceptible to this, and this is extremely expensive because if you can't regulate this important nutrient, your cells are basically starving, and your kidney won't work, and your immune system has trouble because of all this sugar around there. And so this is the leading cause of amputation. It's the leading cause of blindness. It produces infections and poor wound healing. Diabetes is really, really serious, but it is very treatable. We can treat diabetes now, and so it's something that people need to be aware of and need to take seriously. Okay, so I'll stop that one. Did you have any questions? Okay, so so diabetes in the forum for this week, it'll ask you to go in, and it'll say, you know, here's this little thing you can assess your risk of diabetes. It'll ask you a few questions. It'll show you a little bit about diabetes, and then it'll ask you to write about what you know about diabetes, your risk. So assess your risk and relay that to to other students in the forum and what you might do about it. So, okay, any questions? No. All right. Let's see. I think I might have another share, but I'm not sure here. Let me think. Maybe I don't. Okay. I think I just have the reading hints there. Yeah. There's this is, do you see the reading hints? Yes.
Yep.
Okay. So I'm most concerned with the pituitary gland and the pancreas, and look over the forum on diabetes, and then there's a section in the beginning of chapter 13 on endocrine disruptors. There's not a forum on that, but read that over. That's an important type of question that could show up in other places in the quizzes or maybe on an exam. There's lots of words here, lots of hormones. Again, focus on the pituitary gland and on the pancreas. Okay, so I'll stop that. Oh, come on. Let's see if I can get off that. Okay. All right, that's about what I have. It's a hard chapter, a long chapter. Look at it that way. Look at the exams. Look at your things. If you have any questions, then send me an email. Okay?
Okay.
All right, I've got nothing else, so I'm going to stop there. And I will see you hopefully next week. And if in the meantime, if you have anything to send to me, I'll try and watch my email for it, okay?
Okay. Bye.
All right, see you later.